Hey there, statisticians. This is Mr. Gilbertson from Independence High School in Glendale, Arizona. So we're going to start talking about confidence intervals and a lot of confidence intervals in this chapter, chapter 8. But before we do that, I would like to remind you what a point estimator and a point estimate is. A point estimator is the name of the statistic that we are looking for. Okay, so the point estimator is the name. For instance, X bar, mean, P hat, X bar is mean, P hat, we could be doing minimum, median. All of these would be an example of the type of statistic I am looking for. Remember, a statistic comes from a sample, a parameter comes from a population. So the value that is associated with that estimator is the point estimate. So the point estimate will be a number. It'll be the value of X bar or P hat or min or median, etc., etc. All right, so we're going to hit pause here real quick, and then in exercise 8.1, assignment 8.1, I would like you to answer exercises 1 through 4. All right, welcome back. So let's get into the meat and potatoes. Start getting into the meat and potatoes of chapter 8 here. Let's talk about a confidence interval. So what a confidence interval is, it's going to give us an interval of plausible values for a parameter based on our sample data. What does that mean? Well, we are going to say that our values go from a low point to a high point, and we are going to be some percent confident that this happens. That is what a confidence interval is. So we're going to go from a low number to a high number, and we are a certain percent confident that the value we're looking for falls between those two. All right, so that looks like this. So a point estimate is the mean of the endpoints of my interval. So what we are actually going to find, let me move my picture. There, that's a little bit better. So I am going to give you an interval. We're going to go from here to here. Let's say this is, I don't know, let's just come up with a number 10, and this is the number 50. So our point estimate is the value that is halfway between those. So that my point estimate in this case would be 30. Because if you add 10 and 50 and you divide by 2, you get 30. And then our margin of error is the distance between the point estimate and the endpoint. So in this example, my margin of error would be 20 because I can go down 20 from 30 and we can go up 20. And if we are going to be 90% confident or 95% confident or 99% confident that our actual parameter falls someplace between 10 and 50. It may not be 30. We're estimating it to be 30, but we know that's where it falls. So if we look at a 95% confidence interval, now they said we did this earlier, we didn't, but I took it from the book. We are 95% confident for the proportion of all U.S. adults who would admit to experiencing some financial difficulty paying an unexpected bill of $1,000 right away is between 0.613 to 0.687. This interval would look like this. So we would say my low end is going to be 0.613. My high end would be 0.687, and my point estimate is going to be the mean of those 2 points. So whatever we get for this mean, that's my estimate. And that's going to equal, I hate when that happens, is going to equal 0.65. So my point estimate, the point halfway between the two endpoints, is 0.65. There we go. So we have our margin of error then is the difference between the point estimate and one of my endpoints. So the margin of error is going to be 0.65 minus 0.613 minus 0.613. Oh, goodness. And so my margin of error is going to be 0.037. So we are going to go 0.37 to the left of my point estimate and 0.037 to the right of my point estimate. And that is what we call our margin of error. So let's look at how this is done. So if you happen to have a highlighter, please get it out. So because we're going to highlight some stuff, I'm going to go over some stuff. You've got this worked out perfectly here. So a Gallup poll asked a random sample of U.S. adults, would you like to lose weight? Based on this poll, the 95% confidence interval for the population proportion who want to lose weight is 0.56 to 0.62. So on the low end, we think that 56% of U.S. adults want to lose weight, and to the high end, it's 0.62. So interpret this confidence interval. We need to say the following. You are going to, the 95% is right here. We are 95% confident. And then you are going to list your interval, that the interval from 0.56 to 0.62 captures, and you need to say true proportion of all U.S. adults. It's all adults because it's the parameter. And notice everything is in context of losing weight. So be careful. Make sure that you are using the words all and true, because my confidence interval is used to predict the parameter. My point estimate, like I showed you earlier, is going to be the mean of the two endpoints. So p hat, because we're talking proportion of adult Americans, add these two together, divide, I get 0.59. And then my margin of error is the difference between an endpoint and the point estimator. So if we're looking at this and we want to draw a point of our point estimate, my point estimate is going to be at 0.59. That's what I believe P to be. We are going to go down 0.03, and we are going to go up 0.03. When we go down, we will be at my lower one, where'd it go? 0.56. And when we go up, we'll be all the way up at 0.62. And then when we talk about it, when we list this, so based on this poll, Gallup's claimed that more than half of U.S. adults want to lose weight. Use the confidence interval to evaluate the claim. So do we believe that more than half? Well, we're going from, my low end is from 56% up to 62%. So what we're going to say is all the plausible values in the interval are greater than 0.5. We go from 0.56 to 0.62. So there is convincing evidence that more than half of U.S. adults want to lose weight. Notice I answered the question. It asked, is there convincing evidence? Yes, there is convincing evidence. And then this is kind of a funny, it made me chuckle about a wrong way to use confidence intervals, but we kind of get it. So if we take a look at tomorrow's weather, the high temperature will be between 40 below zero and 200 above. And it's like, he's never wrong. Well, of course, because the temperature is never going to, on Earth, will never get below 40 and never above 200. So that would be a confidence interval. That is an interval. And then if you wanted to find the point estimate, add those two values, divide by 2. Alrighty, so this is where we are going to end the video. You are now provided with enough information to turn to assignment 8.1 and do exercises 5 through 11.